think, yeah, you can hear me. Hi, I'm Bonaventure, and today I wanted to share with you our work on shortly our work on pretrained vision models for high risk breast cancer stage prediction. So I'm presenting on behalf of my other co-authors. Um, Briefly, the challenge was given a biopsy, we needed to chunk it into patches or slides, and use those slides actually to predict the stage of the breast cancer that the biopsy would actually lead to. So the go-to approach was technically using pre-trained vision models. So we tried bunch of them. Why? Because obviously we know that they'll require less data, and they could also offer better performance. But it was also a challenge because they've been pre-trained on a very different task, like the ImageNet or things like that. Those data sets do not have anything in common with the type of data we are working with. So it was interesting to see how it's gonna perform. So we tried different models, ranging from ResNet to EfficientNet. I didn't include it, but we also tried some max VIT vision transformers, all those type of things. And turns out that individually they perform better, which was a little bit surprising. They were able to generalize across beyond the domain specific they were trained on, but we found out that building a kind of deep ensemble, putting all those models together and aggregating over the different predictions gave actually way better predictions than individual single models. So at the end, we found out that yes, of course, even those models haven't been trained on on the specific domain that we were working on. They're actually powerful and effective, and the transfer learning in that case will help. And this application of this type of work could actually be very interesting and help doctors in daily diagnosis in detecting breast cancer in early days. So moving forward is going to be potentially scaling the results, finding better hyperparameters and improve the performance. And one thing I'm really interested in is improving exploring how we can use uncertainty quantifications to make the model more robust and improve the overall classification task. So that was it. I hope I was under the 3 minutes, but yeah, if you have any questions, feel free to reach out.